Good day. Welcome to Numeracy. My name is Bruce and I will be your facilitator. Today we're going to be looking at numeracy, and these are the following unit standards which make up this module. These are the 3 unit standards. Then let us have a look and see what is the agenda. The agenda that we're going to be looking at is, firstly, how do you understand number systems, rational and irrational numbers, dealing with shape and motion in 2- and 3-dimensional shapes, and then working with patterns and functions to solve problems. You would receive a learner guide, a workbook, and a portfolio of evidence from the facilitator. At the end of each module, you'll be asked to complete class activities, which you'll be able to complete in your workbooks. At the end of the last module, you'll be asked to complete a portfolio of evidence. Let's move on to module 1. Firstly, how do we understand number systems, rational and irrational numbers? These are the module outcomes. Firstly, to demonstrate understanding of numbers and the relationships among numbers and number systems, and represent numbers in different ways. The use and analyze of computational tools as well as strategies, and make estimates and approximations. Understanding of number systems, rational and irrational numbers. People use maths in their everyday life. When you go to the grocery store, you have to find out if you have enough money. People use numbers every day. You use numbers whenever money, time, weight, height, calories, or distance, for example, are involved. The number systems. Numbers can be classified into sets called number systems. There are various number systems that we use, such as real numbers. The full range of real numbers, which includes decimals that can go on forever and ever without ending. Natural numbers. Natural numbers are greater than 0, but don't include fractions. For example, 1, 2, 3, 4, all the way up, and so on for infinity. Whole numbers. Whole numbers are just all the natural numbers plus 0. So 0, 1, 2, 3, and so on to infinity. Integers. Integers incorporate all the qualities of whole numbers and their opposites, or additive inverses of the whole numbers. Integers can be described as being positive and negative whole numbers. So for example, -3, -2, -1, 0, 1, 2, and 3. Rational numbers. Rational numbers are numbers that act rationally. The decimal ends somewhere or has a repeating pattern, to example 0.6666 or 3.164, 164, 164. Irrational numbers. Irrational numbers are the opposite of rational numbers. An irrational number cannot be written as a fraction, and the decimal values for irrationals never end and never have a nice pattern to it. So example 0, 3, 1, 2, it goes and then goes on forever, but it does not repeat the same pattern. Odd numbers. An odd number is one that does not divide evenly by 2, for example 1, 3, 5, and 7. The decimal number system. In South Africa, we use the decimal system to actually work with numbers. And there you can see tens, units, decimal point, 1/10, hundreds, and thousands. You can see they're bigger and 10 times smaller. Scientific notation. Sometimes we have to have a need to express very large or very small numbers, but in some convenient ways. Let's see how many meters there are in 1 light year. Light travels at a speed of 30 million minutes per second. Sorry, 300 million meters per second. That would be, sure, that's such a long number per year. This number is obviously very inconvenient to read, but also to write. The solution to the problem is to write such a very large or very small numbers in a scientific notation. Scientific notation makes representing units of any size easier. Your scientific notation involves writing a number as a product of 2 numbers. First one, which is a digit value, is always more than 1 and less than 10. The other, which is the exponential term, is expressed as a power of 10. So 3.7 times 10 to the power of minus 11. Using computational tools. Computation is a calculation or working out figures or quantities in order to find a solution. When carrying out calculations, you need to choose reliable, relevant mathematical instruments, which would include calculators and PC programs, for example, of Excel. Mathematical instruments are sometimes also called computational tools. Algorithms. In maths, algorithms are set for rules for solving maths problems, which, if done properly, will give a correct answer each time. Algorithms generally involve repeating a series of steps over and over, as in the borrowing and carrying of algorithms and in the long multiplication and division algorithms. Basic operations refer to the use of your addition, subtraction, division, and multiplication. Algorithms. When following the algorithm, you need to use the BODMAS rule. BODMAS is an acronym comprising of first letters of the 4 basic mathematical operations. Each letter in the word BODMAS stands for the name of a mathematical operation that we would normally find in a mathematical problems with the expressions and equations that need to be computed. The B, as you can see, stands for brackets first. The O, orders, that is exponents to the power of and square roots. The DM stands for division and multiplication from left to right. And the AS, which comes afterwards, is then addition and subtraction from left to right. Here's an example of a BODMAS. How would you work out 3 plus 6 times 2? According to BODMAS, it would be multiplication comes before addition. So first, we would do 6 times 2 equals 12. Then 3 plus 12 equals 15. So how would you work out 3 plus 6 times 2? Well, according to BODMAS, we would do the brackets first. So 3 plus 6, which was 9. And then, because the m comes afterwards, you multiply it by 2 to get 18. Estimates and approximations. Estimation is finding a number that is close enough to the right answer. You are not trying to get the exact right answer. What you want is something that is good enough. Estimations can save you money. Always do a quick estimation of how much you should pay. Approximations. We would work out an approximate answer when we have used rounded numbers to perform a calculation. So we have not used the true figures. It is important to remember that most measurements is approximates. The symbol means approximation equal to, so we would show mathematically that 75.36 times 84.21 is approximately equal to 6,400. Converting between numbers. We convert between fractions, decimal numbers, and percentages daily without actually giving it much thought. For example, half a pizza is written as a fraction, 1/2, or a decimal, 0.5, or as a percentage, which is 50%. Fractions to decimals. When converting a common fraction to a decimal fraction, we use a calculator to divide the numerator by the denominator. This could be done manually. Decimal fractions are derived from dividing the numerator by a denominator. If you divide 1 by 2, you'll get 0.5. If you divide 1 by 4, you'll get 0.25. Please complete class activity 1 in your workbook. Thank you.